All right, you guys, here we go with section 4.5, day 2. Believe it or not, this happens to be the last section of the chapter. Yes, the problems that I skipped in these videos, we're just going to skip altogether. We cut down a little bit of the curriculum, okay? So if you have blanks in your packet, don't worry about that. Anyways, write a formula for the given sequence. So very first thing you want to do for these is, first of all, see if you can identify whether it's arithmetic or geometric. You should be pretty familiar with that by now, but looking at these first two terms, I'm thinking, okay, to go from 1 to 4, that's plus 3. Is it plus 3 again? No. It'd be plus 3, plus 5, plus 7, whatever. Not arithmetic, so I can't use a formula for that. Let's see if it's maybe geometric. 1 times 4 is 4, times 4 again is not 9. So it's not geometric, so I can't use my geometric formula. And that's the thought process. The very first thing you want to do when you're given a sequence is see if you can use any of the formulas that we already have. This is not arithmetic because it's not adding or subtracting the same number every time. And this is also not geometric because it's not multiplying or dividing the same number every time. When that happens, I know you can probably come up with a pattern and you can see that it's adding 3, adding 5, adding 7, adding 9. There is a pattern there, but how the heck do you write a formula for that? So what I would suggest here is when you can't easily identify arithmetic or geometric, if you can rule one of those out, then try just numbering your terms. So the first term is 1, the second term is 2, the third term is 3. Does that help you see what to do in order to figure out maybe what like the 10th term is or the 50th term without having to write all those out? Are you noticing that the term number squared is the actual term? And 2 squared is 4, and 3 squared is 9, and 4 squared is 16. So all I'm doing here is I'm taking the n and I'm squaring it. And that's the formula for this sequence. And so remember, we write formulas as a sub n equals. You just take the n and you square it. So I could easily figure out what the 17th term was. I don't have to write all these out. I just take 17 and square it. And so one of the tricks that's going to help you is if you number these, then sometimes you'll be able to recognize right away what you're supposed to do at the end. Just remember that n is the term number. So like first term, second term, third term, the third term, n is 3. Anyways, let's look at the second one. Okay, 2, 7, 12. Well, I know this is plus 5. This is also plus 5. Oh, snap. It looks like we are adding 5 every single time, so this is arithmetic. So I have a formula for that. Write it right away. This is from the very first section of the chapter, and plug in everything you know. So a sub n equals, the first term is 2. The difference is positive 5. So go ahead and distribute your 5. Be careful algebraically here. 2 plus 5n minus 5. That means I have 5n minus 3 as the formula. So I can come up with any term number. I can come up with the 23rd term by just plugging in 23 right here. You definitely don't want to have to list out all those numbers and add 5 over and over and over again. That's why we have formulas for these. Okay, so this one was arithmetic. I was able to really easily identify, and therefore I can use a formula for that. So don't forget the formulas that we've already learned here. Okay, let's try another one. Let's see. It's not adding because the numbers are getting really big and the signs are alternating. So this is going to be a little bit trickier. Am I multiplying by 4, 16 times 4, 164 times 4? Signs are still alternating though. Let me see if the numbering trick is going to work. If I number these, let's see. Oh, what if it's negative 4 to the n? Will that work? When I take negative 4 and raise it to the first power, I get negative 4. Okay, cool. If I take negative 4 and raise it to the second power, I get positive 16. Okay, cool. Negative 4 to the third is 64. Oh, snap. I think I came up with my formula just by numbering the terms. And sometimes you'll be able to use a little bit of common sense and think your way through here. Did any of you say this is a geometric? What if I just multiply by negative 4 every single time? Isn't that a geometric? So what if, I'm going to show you an alternate way to get this. Yes, common sense works sometimes. Other times, if you're a formula person, you can go that route too. So since this is geometric, I have a formula for that. A sub n equals a1 r n minus 1. Do you remember that? This is for geometric. So that's why those geometric and arithmetic formulas really come in handy. But anyways, my a1 is -4. My r is also -4. Okay, so could I leave it like that? Yes. Would it be okay to multiply these -4's together and make 16? Absolutely not. We have an exponent here, so you cannot multiply these together because this -4 has an exponent. But I bet we can clean this up just a little bit. Would you agree that this -4 has a 1 exponent on it right here? Like if there's not an exponent on a parentheses or on a number, then there's really just a 1 there. So I'm going to put that 1 in. And I'm going to do a little bit of algebra here. That means you can take the -4 because the base is the same for both of them. And can't you add these exponents, this one and this one? So that would be 1 plus n minus 1. Isn't that the same thing as -4 to the n? So just by doing a little bit of algebra, I cleaned it up, and look, I got the same exact answer. So now that we're at the end of the sequences and series chapter, you guys, some of you will be able to use some common sense and come up with a formula by numbering the terms without having to use one of the formulas that we have memorized. If you're like me, formulas are a great thing to always have and use whenever anything else fails. I can't usually come up with the common sense formula right away. It's totally okay. We have a formula here, but I want you to know that you might have to do a little bit of algebra to clean these up. This is the exact same thing as doing x times x to the third. Remember, there's really an x to the first here, and that means x to the fourth because you add the exponents. It's exactly what I did here, except they weren't x's, they were -4's. Okay, so just beware of that. There's a little bit of algebra that takes place here. I'm going to skip number 10 for a second, and I'm going to do 11. With fractions, I tried to preview this in my previous video, but what I'm noticing here is I think the easiest way to do fractions is to look at the numerator separate from the denominator. So 2, 5, 8, 11. Do you notice a pattern there? Isn't that just +3, +3, +3? So it's an arithmetic on the top. And so I have a formula for that. Let's look at the denominators separately. 5, 9, 13. Looks like I'm adding 4 every time to the denominators. So that's cool. So I'm going to use my arithmetic sequence for both, and I'm just going to make a fraction out of both formulas that I come up with. Okay, so I'm going to do the red one first. I have this formula because it's arithmetic. And I'm going to plug in everything I know. The first term is 2. The difference is 3. When I simplify that, I get 3n minus 1. So that is the numerator. Now let's talk about the denominator. I'm going to do the same exact thing. A sub n equals a sub 1 plus n minus 1 times d. In the denominators, my first term is 5. My difference is 4. So I'm going to simplify that, and I'm going to get 4n plus 1. Therefore, my formula for this entire fraction thing, I'm going to put the 3n minus 1 on the top, and I'm going to put the 4n plus 1 on the bottom. Let's see if that works. Let's just check it. You guys know that you can always check these. Let's try n equals 3. That means third term. When I plug in 3 to the numerator, I get 9 minus 1, which is 8. When I plug in 3 to the denominator, I get 12 plus 1, which is 13. That's the third term. Is it the third term? Oh, snap. Third term, it works. So you guys, these are checkable. You can always check a term that you're given by plugging in whatever that term number is for n and make sure that your formula actually works. Okay, let's do this number 10 that I skipped. Notice the similarities between number 9 and number 10. So isn't it the same exact formula? It's just, or the same exact sequence, but the signs are off. So let's see if I can do this -4 thing. I'm noticing that I'm multiplying by -4, and then multiply again by -4, and then multiply again by -4. So that means it's geometric. And so I've got a formula for this. A sub n equals the first term times the ratio times n minus 1. And so in this case, what I'm going to plug in is my first term is +4 in this case. My ratio is -4, and that would leave it to the n minus 1. That is totally cool to be able to leave your answer like that because it's just a basic geometric sequence. But unfortunately, there is something a little bit tricky about this chapter, and there are other ways to correctly write the formula that might look way different for you. So I want to show you another common sense type of way to come up with this without using the formula, because some of you are able to come up with these patterns without using these formulas that we've memorized. What if I did that trick where I numbered all these terms, 1, 2, 3, 4, and it keeps going? So what if I numbered them, and I think that you can pretty easily notice 4 to the first is 4, 4 squared is 16, 4 to the third is 64, 4 to the fourth is 256, but the signs are alternating. This is positive, this is negative, this is positive, this is negative. So another way that this formula could be written in the event of having a multiple choice type of scenario sometime in the future, I just want you to be able to recognize other things. So we are taking 4 to the n, but the signs are alternating because, as you know, these signs are not all positive. So the first one is positive, but the second one's negative, third one's positive, whatever. I touched on this briefly in the first example, in the first video for this section, but I'm also going to have this -1 to the n plus 1. And that is why the signs alternate. And so again, let me plug in my very first term for n, and let's just see if it equals 4. So when I do 4 to the first, and then -1 to the 1 plus 1, what does that equal? 4 to the first is 4, -1 squared is 1, that equals 4. That is my very first term. Let's see if it works for term number 2. 4 squared times -1 to the 2 plus 1. 4 squared is 16, and -1 to the third is -1, so that would be -16. And that is my second term. So yes, there is another way to write this formula by using some common sense, and yes, they look a little bit different. A little bit of algebra to clean up one of them or the other one can help you make sure that they are correct, but I just want you to know that both of these answers will be acceptable. Only thing is, if it were a multiple choice, my suggestion would be to actually plug in the term number to the formulas that you're given and see which one it works for, because these formulas look totally different, but they both yield the correct sequence. Okay, let's move on to a different section. These are a little bit more simple. Expand, step 1, and find the sum, meaning add up all of the numbers if it exists, meaning there might not be sums for all of these. Okay, so for the first thing, remember previously in a different video we had this summation symbol. This means that n starts with 1 and ends with 5, and this is your formula. So if you would like, I would maybe suggest doing that sideways t-chart thing and actually plugging in the 1 to the formula, the 2 to the formula, and I'm starting at 1, which means the first number I'm plugging in is 1, and I'm ending at 5, and so that's why I'm stopping here at 5. Anyways, you can do this part really quickly. When you plug in 1 to the formula, you get 2 plus 3, which is 5. I'm going to label these. When you plug in 2, you get 7. When you plug in 3, you get 9, 11, 13. That's pretty simple, but it does want to know what the sum is. So when you add all of those up, you get 45. Okay, so first of all, expand, that's this part, actually filling out the t-chart, and then find the sum. In this case, we can add all of these together. That gives you 45. So let's do this one. N and A sub n. In this case, I'm starting with 3 and going to 7. So 3, 4, 5, 6, 7. Formula is a little bit simpler. You're just plugging in all of your numbers to n squared. So that would give you 9, 16, 25, 36, 49. And again, finding the sum, 135. So first of all, expand. Second of all, find the sum. Okay, I've got another one. N and A sub n. 1, 2, 3, and 4. plugging all of these numbers in gives us -1, 2, 5, and 8. Sum equals 14. That was pretty simple. These are pretty simple to plug in, and the reason why I'm doing this t-chart method and not using a formula is because there aren't very many numbers that I have to plug in. Okay, just keep that in mind. How about this one? N, A sub n, 2, 3, and 4. Careful here, you're starting with 2 and ending at 4. So when I plug in 2 here, this is kind of like that problem I was just talking about. Plug in 2 right there, and that's going to give you 3 for an exponent. So it's going to be -1 times, plug in 2 also here, which gives you 3. So -1 times 3 is -3. Let's do the same thing for 3. When you plug in 3 here, you get -1 to the 4th, which is +1, so it basically doesn't do anything. And then plug in 3 here and you get 4. Notice my signs are alternating. That's what this does. Negative, positive. Let's do one more. So plug in 4. When we plug in 4 here, you get -1 to the 5th, which is going to be a negative number, and then 4 plus 1 is 5. Okay, so here is again another one of those situations where the signs alternate. So just beware of those. I don't want you to like freak out if you've ever seen that. That's just an alternating signs trick. Okay, how about number 16? Starting at 3 and going to, I don't want to write out all those numbers to infinity. Because it goes to infinity, there is no sum. That means that this is divergent. That's why in the directions it said find the sum if it exists, okay? Because right here, we don't have a sum because it goes to infinity, it goes forever. We're not going to do our t-chart and do all of that stuff because this is divergent. All right, one more part, you guys. Describe the series using sigma notation. So that means that I need this big sigma, and I'm starting with n equals, let's see, let me number these. 1, 2, 3, 4, 5. Okay, I'm starting with n equals 1 and I'm ending with the 5th term. That's how you set up your sigma. And then in this case, are you noticing that we are adding 4 every single time? So this is arithmetic. Remember that formula? A sub n equals a1 plus n minus 1d. Let's plug in all of our stuff. The first term is 2. The difference is, what was it, 4? So that gives me a sub n equals 4n minus 2. That formula goes right here. And that is how you write it using sigma notation. Okay, let's try the second one. Let's see. Looks like my numerator is always 1. So that's kind of cool. See all these 1s? So again, I'm going to start by setting up my sigma. N equals, I'm going to start by first term, second term, third term, fourth term, dot, dot, dot. So it starts with the first term. Where does it end? Infinity, and that is because of these dots. Okay, so beware of those dots. Anyways, it looks like the top is always going to be a 1. So no matter what, I don't even need a formula for that. It's always a 1. But can you decide, maybe I'll make this one into a fraction also. Can you decide what's happening in the denominator? This is a 1, this is an 8, this is a 27. What's happening here? It looks like I'm raising the n, the term number, to the third. It gives me 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. So it's just the term number raised to the third. That one wasn't a formula. It's not arithmetic in the denominator because we're not adding the same number every time. It's also not geometric because we're not multiplying the same number every time. That's when it's going to be helpful to number the terms and see if you can use some common sense to come up with a rule. Okay, just don't lose that 1 that's in the numerator. So that's why it's 1 over n to the third. Okay, last example. Starting with -3, let's see. Looks like I'm multiplying by -3, multiply by -3, multiply by -3. This looks like it's geometric. Okay, so I'm going to write my sigma notation. 1, 2, 3, 4, 5, starting at the first term, ending with the 5th term. And remember, I have an equals a sub 1 r n minus 1 for geometric. So that means that my first term is negative 3. My ratio is always also negative 3 to the n minus 1. I think we should probably clean that up a little bit. You could leave it as negative 3 times another negative 3 to the n minus 1. That's okay. Keep in mind, if it's a multiple choice question at some point, you might have to clean that up algebraically a little bit. Remember that there's an imaginary 1 there, so that means you keep the negative 3 and you add the exponents. And so that would just be the same thing as negative 3 to the n. So you could also write this as summation n equals 1 to 5, negative 3 to the n. Same exact thing. One of them is cleaned up a little bit more algebraically. Both of those answers are acceptable. However, if it's multiple choice type of question, you need to be able to decipher whether or not these answers are equivalent, okay? That's all, you guys. Send your questions to your teacher, and I hope you guys are staying healthy and staying safe and staying sane. Thanks for watching.